The Milky Way is a barred spiral galaxy, which is the galaxy in which our solar system is located. It is estimated to be about 13.6 billion years old and contains hundreds of billions of stars, as well as countless planets, asteroids, and other celestial objects. The Milky Way is approximately 100,000 light-years across, and its thickness varies from about 1,000 to 3,000 light-years. It is shaped like a disk with a central bulge and spiral arms that extend outward. The disk is made up of gas, dust, and stars, while the bulge is composed mostly of older stars. The spiral arms of the Milky Way contain clusters of young stars, gas, and dust that are constantly forming new stars. These arms are thought to be caused by density waves that create areas of higher concentration of gas and dust, which in turn leads to the formation of new stars. The center of the Milky Way contains a supermassive black hole, which has a mass estimated to be about 4 million times that of the Sun. This black hole is surrounded by a region of intense radiation known as the Sagittarius A star. The Milky Way is just one of many galaxies in the universe, but it holds a special place in our hearts as it is our home galaxy. Thanks to its relative proximity, astronomers have been able to study it in great detail, allowing us to learn more about the formation and evolution of galaxies in general. Overall, the Milky Way is an awe-inspiring and fascinating object that reminds us of the vastness and complexity of the universe. In addition to its size and structure, the Milky Way is also home to a number of interesting phenomena, such as supernovae, pulsars, and nebulae. Supernovae are massive explosions that occur when a star reaches the end of its life, while pulsars are highly magnetized, rotating neutron stars that emit beams of electromagnetic radiation. One of the most well-known nebulae in the Milky Way is the Orion Nebula, which is a massive cloud of gas and dust that is actively forming new stars. Another famous nebula is the Eagle Nebula, which contains the famous pillars of creation, towering structures of gas and dust that are in the process of forming new stars. The Milky Way is also home to a number of satellite galaxies, including the Large and Small Magellanic Clouds, which are visible in the night sky from the southern hemisphere. These satellite galaxies are much smaller than the Milky Way and are thought to have been gravitationally captured by our galaxy billions of years ago. The study of the Milky Way and other galaxies has helped astronomers to develop a better understanding of the structure and evolution of the universe as a whole. By studying the movement and distribution of stars and galaxies, scientists have been able to develop models of how the universe formed and evolved over time. Overall, the Milky Way is a fascinating object that continues to captivate scientists and amateur astronomers alike. As our understanding of the universe continues to grow, we can expect to learn even more about this incredible galaxy and the mysteries that it holds. The Milky Way has played an important role in the history and development of human civilization. For centuries, people have been fascinated by the night sky, and the Milky Way has been a prominent feature in myths and legends from many cultures around the world. In addition to its cultural significance, the Milky Way has also been instrumental in scientific research. Astronomers have used the galaxy as a laboratory to study a wide range of astrophysical phenomena, including dark matter, gravitational waves, and the search for extraterrestrial life. One of the most important discoveries related to the Milky Way is the concept of galactic cannibalism. This refers to the process by which larger galaxies, such as the Milky Way, can absorb and consume smaller galaxies that orbit around them. The evidence for this phenomenon has been observed in the form of dwarf galaxies that have been found in close proximity to the Milky Way. The Milky Way has also been a target for space exploration. In the 1970s, NASA launched the Voyager 1 and Voyager 2 spacecraft, which have since traveled beyond the boundaries of our solar system and into interstellar space. These spacecraft have provided scientists with valuable information about the structure and composition of the Milky Way and other galaxies. Today, astronomers continue to study the Milky Way using a wide range of observational tools, including telescopes, satellites, and computer simulations. With each new discovery, our understanding of the galaxy and its place in the universe grows, reminding us of the beauty and complexity of the cosmos that surrounds us. Recent advancements in technology have allowed scientists to explore the Milky Way in greater detail than ever before. In particular, telescopes and observatories operating in the radio, infrared, and X-ray portions of the electromagnetic spectrum have provided new insights into the galaxy's structure, evolution, and composition. One notable example is the Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile, which is a collection of 66 radio telescopes that work together to produce high-resolution images of the Milky Way and other galaxies. The observations from ALMA have helped astronomers to study the distribution of gas and dust in the Milky Way, as well as the formation of stars and planets. Another important development is the use of gravitational wave detectors to study the Milky Way and other galaxies. Gravitational waves are ripples in the fabric of spacetime caused by massive objects, such as black holes and neutron stars, colliding with each other. By detecting these waves, scientists have been able to study the properties of these objects and gain new insights into the structure and evolution of the Milky Way. Finally, the search for life beyond Earth has also focused on the Milky Way, as it is believed to be one of the most promising places in the universe to find habitable planets. Recent discoveries of exoplanets, or planets that orbit stars other than the Sun, have suggested that there may be billions of potentially habitable worlds in the Milky Way alone. In summary, the Milky Way is a vast and complex object that continues to fascinate and inspire scientists and the public alike. Through ongoing research and exploration, we can expect to learn even more about this incredible galaxy and the mysteries that it holds. One of the most exciting areas of research related to the Milky Way is the search for dark matter. Dark matter is a type of matter that does not interact with light or other forms of electromagnetic radiation, making it invisible to telescopes and other observational tools. However, its presence can be inferred from its gravitational effects on visible matter. Scientists believe that dark matter makes up around 85% of the matter in the universe, including the Milky Way. The search for dark matter is a major focus of modern astrophysics, and many experiments are underway around the world to try and detect this elusive substance. In addition to the search for dark matter, astronomers are also interested in the role that the Milky Way has played in the history of the universe. The galaxy is thought to have formed around 13.6 billion years ago, shortly after the Big Bang, and it has been evolving and changing ever since. By studying the Milky Way and other galaxies, scientists have been able to develop models of how the universe has evolved over time, from its early moments to the present day. These models have helped us to understand the origins of the universe, the nature of dark matter and dark energy, and the distribution of galaxies and other large-scale structures. Finally, the study of the Milky Way has important implications for our understanding of our place in the universe. By exploring the galaxy and its properties, we are able to gain a deeper appreciation for the vastness and complexity of the cosmos. We are reminded that we are but a small part of a much larger whole, and that there is still so much left to discover and explore. One of the most fascinating aspects of the Milky Way is the sheer size and complexity of the galaxy. It is estimated to be around 100,000 light-years in diameter and contains hundreds of billions of stars, as well as countless planets, asteroids, and other objects. The Milky Way is also home to a number of interesting and unusual astronomical objects. For example, it contains several massive black holes, including one at the center of the galaxy that is estimated to have a mass of over 4 million times that of the Sun. The galaxy also has a number of star-forming regions, such as the Orion Nebula, which are responsible for the creation of new stars and planets. These regions are some of the most active and dynamic parts of the Milky Way, and they provide important clues about the processes that govern the formation and evolution of galaxies. Another interesting aspect of the Milky Way is its halo, which is a region of hot, ionized gas that surrounds the galaxy. The halo is thought to be the remnant of past supernova explosions and other energetic events, and it contains a wealth of information about the history of the Milky Way and the processes that have shaped it over time. Finally, the study of the Milky Way has important implications for our understanding of the origins and evolution of life in the universe. By studying the properties and characteristics of our own galaxy, we are able to develop models of how habitable planets might form and evolve in other parts of the universe. This has important implications for the search for extraterrestrial life, as well as for our understanding of the potential for life beyond Earth. In summary, the Milky Way is a fascinating and complex object that continues to capture the imagination of scientists and the public alike. Through ongoing research and exploration, we can expect to learn even more about this incredible galaxy and the mysteries that it holds. One of the most exciting developments in the study of the Milky Way is the use of new technologies and techniques to explore the galaxy in ever greater detail. For example, the upcoming James Webb Space Telescope, set to launch in 2021, is expected to revolutionize our understanding of the Milky Way and other galaxies. The James Webb Space Telescope is a collaboration between NASA, the European Space Agency, and the Canadian Space Agency, and it is designed to observe the universe in the infrared portion of the electromagnetic spectrum. This will allow it to study the early universe, the formation and evolution of galaxies, and the processes that drive star and planet formation. Another exciting development in the study of the Milky Way is the use of machine learning and artificial intelligence techniques to analyze and interpret large datasets. With the vast amount of data that is being collected by telescopes and observatories around the world, it is becoming increasingly important to develop new tools and techniques to analyze and make sense of this information. Machine learning and artificial intelligence techniques can help scientists to identify patterns and trends in large datasets, and to develop new models and theories based on this information. This has the potential to revolutionize our understanding of the Milky Way and other galaxies, and to open up new avenues of research in astronomy and astrophysics. Finally, the study of the Milky Way is important not only for its scientific value, but also for its cultural and historical significance. The galaxy has been a source of inspiration for artists, writers, and philosophers for thousands of years, and it continues to capture the imagination of people around the world. By studying the Milky Way and sharing our knowledge and discoveries with the public, we can help to inspire and educate future generations of scientists and explorers. This has important implications for the future of science and technology, and for our understanding of our place in the universe. The study of the Milky Way also has practical applications beyond the field of astronomy. For example, the technology and techniques used to study the galaxy can be applied to a wide range of industries and fields, from medicine to materials science. One example of this is the use of image processing techniques developed for astronomy to improve medical imaging technologies. By using algorithms and software originally designed to enhance images of distant galaxies, researchers have been able to improve the resolution and clarity of medical images, making it easier to detect and diagnose diseases. Similarly, the study of the Milky Way can also help us to develop new materials and technologies that have important applications in fields such as energy, transportation, and communications. For example, the development of new materials for solar cells or battery technology can be informed by our understanding of the processes that drive energy production and storage in stars. Finally, the study of the Milky Way can also help us to address important questions about the future of our planet and our species. By studying the history and evolution of the galaxy, we can gain insight into the long-term prospects for life in the universe, and the potential threats that may arise in the future. This has important implications for our understanding of the environmental and social challenges that we face today, and for the development of policies and technologies that can help us to address these challenges and create a more sustainable future. In summary, the study of the Milky Way is an incredibly rich and diverse field of research with important implications for science, technology, culture, and society. By continuing to explore and investigate this fascinating galaxy, we can hope to unlock even more of its secrets and mysteries, and to use this knowledge to address some of the most pressing challenges of our time. One of the most exciting aspects of the study of the Milky Way is the ongoing search for extraterrestrial life. The vast size and complexity of the galaxy suggest that the conditions for life may exist on countless other planets and moons throughout the galaxy. One approach to searching for extraterrestrial life is to focus on finding habitable planets. A habitable planet is one that is located in the Goldilocks zone, around its star, the region where conditions are just right for liquid water to exist on the planet's surface. Water is essential for life as we know it, so the discovery of habitable planets is a key step towards finding extraterrestrial life. Another area of research in the study of the Milky Way is the study of dark matter. Dark matter is a mysterious substance that is believed to make up a significant portion of the mass of the galaxy, yet it does not interact with light or other forms of electromagnetic radiation, making it very difficult to detect. The study of dark matter is important because it can help us to better understand the structure and evolution of the galaxy. By studying the way that dark matter interacts with visible matter, such as stars and gas, astronomers can infer the distribution and properties of dark matter within the galaxy. Recent observations have suggested that dark matter may play a crucial role in shaping the structure and dynamics of the Milky Way. For example, it is thought to be responsible for the observed rotation of stars and gas in the galaxy, as well as the way that galaxies cluster together in large groups and clusters. Understanding the nature of dark matter is one of the most important challenges in modern astronomy, and it has important implications for our understanding of the universe as a whole. By studying the properties of dark matter and its interaction with visible matter, we can hope to gain new insights into the nature of the universe and the forces that govern its evolution. In addition to dark matter, the study of the Milky Way also involves the study of other exotic and mysterious objects, such as black holes, neutron stars, and supernovae. These objects are some of the most extreme and powerful phenomena in the universe, and they play a key role in shaping the structure and evolution of the galaxy. Overall, the study of the Milky Way is an incredibly rich and diverse field of research that has important implications for our understanding of the universe and our place within it. From the search for extraterrestrial life to the study of dark matter and other exotic objects, the ongoing exploration and investigation of this fascinating galaxy continues to inspire and challenge scientists and researchers around the world. Another interesting aspect of the study of the Milky Way is the way that it has influenced human culture and history. For thousands of years, humans have looked up at the night sky and marveled at the beauty and mystery of the Milky Way. Many ancient cultures, such as the Greeks and the Mayans, incorporated the Milky Way into their mythology and beliefs, viewing it as a powerful and spiritual force. In more recent history, the Milky Way has played an important role in the development of modern astronomy and space exploration. The study of the Milky Way has helped us to better understand the nature of our own solar system, and it has led to important discoveries such as the existence of black holes and other exotic objects. The Milky Way has also inspired countless works of art, literature, and music. From Vincent van Gogh's iconic Starry Night to the Beatles' psychedelic anthem Lucy in the Sky with Diamonds, the galaxy has been a source of inspiration and creativity for generations of artists and musicians. Today, the Milky Way continues to capture the imagination of people around the world. Through the use of powerful telescopes and other advanced technologies, scientists and researchers are able to explore and investigate the galaxy in ways that were once unimaginable. Whether through the search for extraterrestrial life, the study of dark matter, or the exploration of exotic objects, the study of the Milky Way is sure to remain a rich and fascinating field of research for many years to come. The study of the Milky Way has also led to a deeper understanding of the concept of cosmic evolution. By studying the structure and dynamics of the galaxy, astronomers can gain insights into the way that galaxies form and evolve over time. This research has important implications for our understanding of the history and evolution of the universe as a whole. One key area of research in this field is the study of galactic mergers and interactions. As galaxies collide and merge with one another, they can undergo dramatic changes in structure and composition. By studying the effects of these collisions, astronomers can gain insights into the way that galaxies evolve and how the universe has changed over time. Another important area of research in the study of the Milky Way is the search for habitable planets and extraterrestrial life. Over the past several decades, astronomers have discovered thousands of planets outside of our solar system, many of which are in the habitable zone, around their host star, the region where temperatures are just right for liquid water to exist on the surface. The search for habitable planets is of great interest because it raises the possibility that we are not alone in the universe. By studying the atmospheres and compositions of these planets, scientists can begin to infer the presence of life and potentially even detect signs of intelligent civilizations. Overall, the study of the Milky Way is a vast and multidisciplinary field that encompasses many different areas of research, from the study of dark matter and exotic objects to the search for habitable planets and extraterrestrial life. Through ongoing exploration and investigation, astronomers and researchers continue to uncover new insights into the nature of the galaxy and the universe as a whole. In addition to its scientific and cultural significance, the study of the Milky Way also has practical applications in areas such as navigation and satellite communication. The Milky Way serves as a useful landmark for navigation, particularly for those traveling in the southern hemisphere where it is visible year-round. In fact, ancient Polynesian navigators were able to use the position of the Milky Way to guide their boats across vast stretches of open ocean. Today, the Milky Way is also used as a reference point for satellite communication. Because the galaxy is so far away, it appears essentially fixed in the sky, providing a stable reference point for satellites to lock onto as they orbit the Earth. The study of the Milky Way also has important implications for the future of space exploration. As we continue to explore and investigate the galaxy, we may one day be able to send missions to study its many unique and fascinating features, such as black holes, supernovae, and other exotic objects. These missions could help us to better understand the nature of the universe and our place within it, and they could pave the way for future missions to other galaxies and beyond. Overall, the study of the Milky Way is a rich and fascinating field of research that has important implications for our understanding of the universe and our place within it. From its scientific and cultural significance to its practical applications in navigation and satellite communication, the ongoing exploration and investigation of this amazing galaxy continues to inspire and captivate people around the world. One of the most exciting areas of research in the study of the Milky Way is the search for dark matter. Dark matter is a mysterious substance that is believed to make up a significant portion of the total matter in the universe, yet it does not emit or interact with light in any way that we can detect. The search for dark matter is of great importance because it could help us to understand the underlying structure and evolution of the universe. One promising technique for detecting dark matter is through the study of the motions of stars and other objects in the Milky Way. By observing how these objects move and interact with each other, scientists can infer the presence of dark matter and begin to understand its properties. Another exciting area of research in the study of the Milky Way is the search for gravitational waves. Gravitational waves are ripples in the fabric of spacetime that are produced by some of the most violent events in the universe, such as the collision of two black holes. By studying the effects of these waves, scientists can gain insights into the nature of space and time itself. The detection of gravitational waves is an important goal for modern astronomy, and many telescopes and observatories are currently being developed to search for these elusive signals. By studying the Milky Way and other galaxies, astronomers hope to gain a better understanding of the conditions and events that produce gravitational waves, and to eventually detect and study these waves directly. Overall, the study of the Milky Way is a constantly evolving and dynamic field of research, with new discoveries and insights being made all the time. From the search for dark matter and gravitational waves to the exploration of exotic objects and the search for extraterrestrial life, the study of the Milky Way is sure to remain a rich and exciting field of research for many years to come. Another important area of research in the study of the Milky Way is the investigation of its magnetic field. The Milky Way's magnetic field is thought to be generated by the motions of charged particles, such as cosmic rays and plasma, within the galaxy. This magnetic field plays a crucial role in many different processes, including the formation and evolution of stars and the regulation of the flow of gas and dust within the galaxy. One of the key tools for studying the Milky Way's magnetic field is radio astronomy. Radio telescopes can detect the radio emissions produced by charged particles moving within the galaxy, allowing astronomers to map out the structure and properties of the magnetic field. The study of the Milky Way's magnetic field has important implications for our understanding of many different astrophysical phenomena, including the formation of stars and planets, the dynamics of the interstellar medium, and the behavior of black holes and other exotic objects. By understanding the role that the magnetic field plays in these processes, astronomers can gain insights into the underlying physical principles that govern the behavior of matter and energy on a cosmic scale. In addition to its scientific importance, the study of the Milky Way also has significant cultural and historical significance. The galaxy has been an object of fascination and wonder for human beings for thousands of years, and it has played a central role in many different cultures and belief systems throughout history. From the ancient Greeks and their myths of the milk spilt by Hera, to the Aboriginal peoples of Australia and their emu in the sky constellation, the Milky Way has been a source of inspiration and spiritual significance for people around the world. Today, it continues to capture the imaginations of people of all ages and backgrounds, and its ongoing exploration and investigation promise to yield many new and exciting discoveries in the years to come. One of the most fascinating aspects of the Milky Way is its vast and complex structure. The galaxy is a swirling mass of stars, gas, dust, and dark matter, arranged in a spiral pattern that extends out from a central bar-shaped region. The spiral arms are home to dense regions of gas and dust, where new stars are forming, and are also populated by older stars and stellar remnants, such as white dwarfs and neutron stars. The study of the structure and dynamics of the Milky Way is a major focus of modern astronomy. By observing the positions and motions of stars and other objects within the galaxy, astronomers can create detailed maps of its structure and trace out its history and evolution. One of the most exciting recent developments in the study of the Milky Way is the discovery of a number of streams of stars and gas that have been torn from smaller satellite galaxies as they orbit the Milky Way. These streams provide valuable clues to the history of the Milky Way and its interactions with its smaller neighbors. Another intriguing aspect of the Milky Way's structure is the presence of a massive black hole at its center. This black hole, known as Sagittarius A*, has a mass of several million times that of the Sun and is surrounded by a swirling disk of gas and dust. The study of the black hole and its environment is a major focus of research in astrophysics, as it provides a unique laboratory for testing our understanding of the laws of gravity and the behavior of matter under extreme conditions. Overall, the study of the structure and dynamics of the Milky Way is a central theme in modern astronomy, providing valuable insights into the evolution of galaxies and the processes that shape the universe on the largest scales. With new telescopes and observatories being developed all the time, we can look forward to many exciting discoveries in the years and decades to come. One of the most exciting developments in the study of the Milky Way is the use of large-scale surveys to map out the properties of the galaxy in unprecedented detail. In recent years, a number of ambitious projects have been launched to map out the positions and motions of millions of stars within the Milky Way, providing valuable insights into its structure, dynamics, and history. One of the most important of these surveys is the European Space Agency's Gaia mission, which is currently in the process of creating the most detailed 3D map of the Milky Way ever made. Gaia is designed to measure the positions, motions, and properties of more than 1 billion stars in the galaxy, with the goal of understanding its structure and evolution on a level never before possible. Other surveys, such as the Sloan Digital Sky Survey and the Dark Energy Survey, are focused on mapping out the large-scale distribution of matter within the universe, including the Milky Way and its surrounding regions. These surveys are helping astronomers to better understand the large-scale structure and evolution of the universe, and to uncover new clues about the nature of dark matter and dark energy, which together make up more than 95% of the mass energy content of the universe. Another fascinating aspect of the Milky Way is its relationship to the broader context of the universe. The galaxy is part of a vast network of galaxies known as the Local Group, which also includes the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller satellite galaxies. The Local Group is just one small corner of the observable universe, which contains billions of galaxies spread out across vast distances. By studying the Milky Way and its neighbors, astronomers can gain insights into the properties of galaxies and the processes that govern their evolution on a cosmic scale. One of the most exciting recent developments in the study of the universe is the use of gravitational waves to probe the structure and evolution of galaxies and other cosmic objects. Gravitational waves are ripples in the fabric of spacetime caused by the motion of massive objects, such as black holes and neutron stars. By detecting these waves and analyzing their properties, astronomers can gain insights into the properties and behavior of these objects, and can test our understanding of the laws of gravity and the behavior of matter under extreme conditions. The study of the Milky Way and the broader universe is a truly awe-inspiring field, encompassing everything from the smallest subatomic particles to the largest structures in the universe. With ongoing advances in technology and our understanding of the fundamental laws of nature, we can look forward to many more exciting discoveries and breakthroughs in the years and decades to come. One of the most intriguing mysteries surrounding the Milky Way is the presence of dark matter, an elusive form of matter that does not interact with light or other forms of electromagnetic radiation. Despite its invisible nature, astronomers have inferred the existence of dark matter through its gravitational effects on visible matter, including stars and galaxies. According to current models, dark matter is thought to make up approximately 85% of the total matter in the universe, with the remaining 15% consisting of ordinary matter such as protons, neutrons, and electrons. The nature of dark matter remains a topic of intense research and debate, with a number of different theoretical models proposed to explain its properties and behavior. Another area of active research is the search for habitable planets around other stars within the Milky Way. In recent years, astronomers have detected thousands of exoplanets, planets that orbit stars other than our Sun, using a variety of techniques, including the transit method and the radial velocity method. While most exoplanets discovered to date are too large or too hot to support life as we know it, a growing number of potentially habitable worlds have been identified, including some that may be located within the habitable zone, the range of distances from a star where liquid water can exist on the surface of a planet. The search for habitable exoplanets is a fascinating field with the potential to revolutionize our understanding of the possibility of life beyond our solar system. Overall, the study of the Milky Way and its place in the universe is a constantly evolving field, with new discoveries and breakthroughs being made all the time. As our technology and our understanding of the laws of nature continue to advance, we can look forward to many more exciting developments in the years and decades to come. Another important area of research related to the Milky Way is the study of its formation and evolution over time. Current models suggest that the galaxy formed through the gradual accretion of gas and dust over billions of years, with stars and other structures forming through the process of gravitational collapse. In the early stages of its evolution, the Milky Way may have been much smaller and less complex than it is today, with the current disk and spiral arm structure forming over time through a combination of gravitational interactions and other processes. By studying the chemical composition, age, and motion of stars within the galaxy, astronomers can gain insights into its formation and history, including the role of factors such as mergers with other galaxies and the influence of dark matter. One of the most exciting recent developments in the study of the Milky Way has been the use of large-scale surveys to map the positions, velocities, and properties of millions of stars within the galaxy. These surveys, such as the Gaia mission launched by the European Space Agency in 2013, have enabled astronomers to create detailed three-dimensional maps of the Milky Way and its structure, and have revealed a wealth of information about the distribution and properties of stars and other objects within the galaxy. In addition to its scientific importance, the Milky Way holds a special place in human culture and history, serving as a source of inspiration and wonder for people around the world for thousands of years. From the ancient Greeks and Romans to modern-day astronomers and stargazers, the galaxy has captivated the human imagination and inspired countless works of art, literature, and music. As we continue to explore and study the Milky Way and the broader universe, we can look forward to many more exciting discoveries and breakthroughs, deepening our understanding of the fundamental laws of nature and our place in the cosmos. Another fascinating aspect of the Milky Way is its supermassive black hole, located at the center of the galaxy. This black hole, known as Sagittarius A*, has a mass of approximately 4 million times that of the Sun, and is surrounded by a disk of gas and dust that is being slowly consumed by its gravitational pull. While black holes themselves are invisible, astronomers can observe their effects on nearby matter and radiation, and have used a variety of techniques to study the behavior and properties of Sagittarius A star. These studies have revealed a number of interesting phenomena, including the presence of high-energy jets of particles emanating from the black hole, and the periodic flaring of X-ray emissions from the surrounding disk. The study of black holes, including those located within the Milky Way, is an important area of research in astrophysics, with implications for our understanding of the nature of gravity, the behavior of matter under extreme conditions, and the evolution of galaxies over time. In addition to its scientific importance, the Milky Way also plays a significant cultural and spiritual role for many people around the world. From ancient cosmologies and creation myths to modern-day astronomy and astrobiology, the galaxy continues to inspire wonder, awe, and a sense of connection to the wider universe. As we continue to explore and study the Milky Way, we can look forward to many more discoveries and breakthroughs, expanding our knowledge and understanding of this magnificent and mysterious object that has captivated the human imagination for centuries. Another fascinating aspect of the Milky Way is the search for extraterrestrial life. The question of whether life exists elsewhere in the universe has captivated scientists and the general public for generations, and the Milky Way provides a unique opportunity to search for signs of life beyond Earth. One approach to this search is to look for evidence of habitable planets, which are planets that are located within the habitable zone of their parent star, the region where conditions may be suitable for liquid water and potentially other conditions necessary for life as we know it. Astronomers have used a variety of techniques to identify and study exoplanets within the Milky Way, including the transit method, which involves measuring the dimming of a star's light as a planet passes in front of it, and the radial velocity method, which involves detecting the small wobble in a star's motion caused by the gravitational tug of an orbiting planet. While the search for habitable planets is a promising approach, it is also possible that life could exist in environments that are very different from those on Earth, such as in the subsurface oceans of icy moons like Europa and Enceladus, or in the high-pressure and temperature conditions of super-Earths and gas giants. As we continue to explore and study the Milky Way, the search for extraterrestrial life will remain a key area of research, with the potential to transform our understanding of the universe and our place within it. Whether we discover signs of life elsewhere in the galaxy or not, the search for extraterrestrial life has the power to inspire and unite us in our shared curiosity and wonder about the mysteries of the universe. The study of the Milky Way also has important implications for our understanding of the evolution of galaxies and the universe as a whole. By studying the structure, composition, and behavior of the Milky Way, astronomers can gain insights into the processes that have shaped and continue to shape galaxies over billions of years. For example, the distribution and motion of stars within the Milky Way can provide clues about the history of the galaxy's formation and evolution, including the role of mergers and collisions with other galaxies, the influence of dark matter on the distribution of matter and energy within the galaxy, and the effects of star formation and supernova explosions on the surrounding gas and dust. In addition, The Milky Way is part of a larger group of galaxies known as the Local Group, which includes other nearby galaxies such as the Andromeda Galaxy and the Triangulum Galaxy. By studying the interactions and dynamics of galaxies within the Local Group, astronomers can gain insights into the larger-scale structure and evolution of the universe. Overall, the study of the Milky Way offers a wealth of opportunities for scientific discovery and exploration, from the search for extraterrestrial life to the understanding of the origins and evolution of the universe itself. As technology and methods continue to advance, we can look forward to many more exciting discoveries and breakthroughs in the years and decades to come. One of the most interesting and mysterious aspects of the Milky Way is the existence of dark matter. Dark matter is a type of matter that does not interact with light or other forms of electromagnetic radiation, which makes it difficult to detect and study directly. However, its presence can be inferred through its gravitational effects on visible matter, such as stars and galaxies. Scientists estimate that dark matter makes up around 85% of the total matter in the universe, including within the Milky Way. The exact nature of dark matter is still unknown, but it is believed to be made up of particles that are not part of the standard model of particle physics. The study of dark matter within the Milky Way is important for understanding the galaxy's overall structure and dynamics. For example, the distribution of dark matter within the galaxy can affect the motion of stars and other visible matter, as well as the overall shape and size of the galaxy. Astronomers use a variety of techniques, including gravitational lensing and the study of the motion of stars within the galaxy, to infer the presence and distribution of dark matter. In addition, the search for dark matter particles has important implications for our understanding of the universe as a whole. The detection of dark matter particles could help to answer some of the most fundamental questions in physics, such as the nature of the universe's dark energy and the relationship between gravity and the other fundamental forces of nature. Overall, the study of dark matter within the Milky Way is an important and ongoing area of research that has the potential to transform our understanding of the universe and our place within it. Another fascinating aspect of the Milky Way is the presence of black holes. A black hole is a region of space-time where the gravitational pull is so strong that nothing, not even light, can escape its grasp. Black holes can form when massive stars collapse in on themselves or through the merging of two or more smaller black holes. The Milky Way is home to a supermassive black hole, known as Sagittarius A*, which is located at the center of the galaxy. This black hole has a mass of around 4 million times that of the Sun and is surrounded by a dense cluster of stars that orbit around it. The study of black holes within the Milky Way is important for understanding the evolution and behavior of galaxies as a whole. For example, the presence of a supermassive black hole at the center of a galaxy can affect the motion of stars and other matter within the galaxy, as well as the overall structure and size of the galaxy itself. In addition, black holes provide important opportunities for scientific discovery and exploration. By studying the behavior of matter as it falls into a black hole, astronomers can gain insights into the properties of space-time and the nature of gravity. Recent advances in technology, such as the development of gravitational wave detectors, have opened up new avenues for studying black holes and other astrophysical phenomena within the Milky Way and beyond. As these technologies continue to improve, we can look forward to even more exciting discoveries and breakthroughs in our understanding of the universe. Another interesting aspect of the Milky Way is its history and evolution. The galaxy is estimated to be around 13.6 billion years old, and its formation and evolution have been shaped by a complex interplay of factors, including the distribution of matter in the early universe, the growth of supermassive black holes, and the mergers of smaller galaxies. One theory for the formation of the Milky Way suggests that it was formed through the merging of smaller galaxies over billions of years. As these galaxies collided and merged, they brought with them stars, gas, and other matter that eventually coalesced into the structure we see today. Over time, the Milky Way has continued to evolve, with new stars forming and old stars dying out. The galaxy's structure and dynamics are also affected by the presence of dark matter, which influences the distribution of visible matter and the motion of stars and other objects within the galaxy. Studying the history and evolution of the Milky Way can provide important insights into the origins and evolution of galaxies as a whole. By analyzing the properties of stars and other objects within the galaxy, astronomers can gain insights into the conditions that existed in the early universe and the processes that shaped the formation and growth of galaxies over billions of years. Overall, the study of the Milky Way is a complex and ongoing area of research that continues to yield new insights and discoveries. As technology and scientific techniques continue to improve, we can look forward to even more exciting discoveries and breakthroughs in our understanding of this fascinating and mysterious galaxy. Another fascinating aspect of the Milky Way is the presence of numerous star clusters, which are groups of stars that are bound together by their mutual gravitational attraction. These clusters can be classified into two main types: globular clusters and open clusters. Globular clusters are densely packed groups of stars that typically contain hundreds of thousands or even millions of stars. They are usually found in the outer regions of the galaxy and are thought to have formed early in the history of the Milky Way. Open clusters, on the other hand, are looser and less densely packed than globular clusters and typically contain only a few hundred to a few thousand stars. They are often found in the disk of the galaxy and are thought to be younger than globular clusters. The study of star clusters within the Milky Way is important for understanding the formation and evolution of stars and galaxies. By studying the properties of individual stars within these clusters, astronomers can gain insights into the conditions that existed when the stars formed and how they have evolved over time. In addition, star clusters provide important opportunities for studying the properties of dark matter, which is thought to make up the majority of the matter in the universe but cannot be directly observed. By studying the motion of stars within star clusters, astronomers can measure the distribution of dark matter and gain insights into its properties. Overall, the study of star clusters within the Milky Way is an important area of research that continues to yield new insights and discoveries. As technology and scientific techniques continue to improve, we can look forward to even more exciting discoveries and breakthroughs in our understanding of these fascinating objects. Another interesting feature of the Milky Way is the presence of a large number of supernova remnants, which are the remains of stars that have exploded in violent supernova events. These remnants can be studied to gain insights into the processes that govern the lives and deaths of stars, as well as the evolution of the galaxy as a whole. Supernova explosions occur when a massive star runs out of fuel and collapses in on itself, triggering a massive explosion that releases an enormous amount of energy and ejects material out into space. This material can be observed as a supernova remnant, which typically consists of a shell of expanding gas and dust surrounding a compact object such as a neutron star or black hole. By studying the properties of supernova remnants, astronomers can gain insights into the conditions that existed during the explosion, as well as the processes that govern the behavior of matter under extreme conditions. In addition, these remnants can be used to measure the rate of supernova events within the galaxy and to gain insights into the chemical composition of the interstellar medium. Overall, the study of supernova remnants within the Milky Way is an important area of research that continues to yield new insights and discoveries. As technology and scientific techniques continue to improve, we can look forward to even more exciting discoveries and breakthroughs in our understanding of these fascinating objects and the processes that govern the evolution of the galaxy as a whole. Another interesting feature of the Milky Way is the presence of a massive black hole at its center. This black hole, known as Sagittarius A*, pronounced Sagittarius A star, has a mass of about 4 million times that of the Sun and is surrounded by a disk of gas and dust that is spiraling towards it. The study of Sagittarius A** and other black holes within the Milky Way is important for understanding the fundamental properties of gravity and the nature of spacetime. Black holes are regions of spacetime where gravity is so strong that nothing, not even light, can escape. By studying the behavior of matter and radiation in the vicinity of black holes, astronomers can gain insights into the properties of spacetime and the behavior of matter under extreme conditions. In addition to Sagittarius A*, there are also a number of other black holes that have been identified within the Milky Way, many of which are thought to have formed as a result of the collapse of massive stars. By studying the properties of these black holes and the surrounding matter, astronomers can gain insights into the processes that govern the lives and deaths of stars, as well as the evolution of the galaxy as a whole. Overall, the study of black holes within the Milky Way is an important area of research that continues to yield new insights and discoveries. As technology and scientific techniques continue to improve, we can look forward to even more exciting discoveries and breakthroughs in our understanding of these fascinating objects and the fundamental nature of the universe. Another fascinating aspect of the Milky Way is the existence of various astronomical phenomena that can be observed with the naked eye or with basic equipment. One of these phenomena is the visible band of light known as the Milky Way galaxy, which can be seen from many locations on Earth as a bright band of stars and dust stretching across the sky. In addition to the Milky Way band, there are also many other astronomical phenomena that can be observed within the galaxy. These include various types of nebulae, which are clouds of gas and dust that are illuminated by nearby stars, as well as clusters of stars and globular clusters, which are groups of stars that are held together by gravity. Observations of these phenomena can provide insights into the structure and evolution of the Milky Way, as well as the processes that govern the formation and evolution of stars and galaxies in general. By studying the properties of these objects, astronomers can gain insights into the chemical composition and dynamics of the interstellar medium, the mechanisms that drive star formation, and the evolution of galaxies over time. Overall, the study of astronomical phenomena within the Milky Way is an important area of research that continues to yield new insights and discoveries. As technology and scientific techniques continue to improve, we can look forward to even more exciting discoveries and breakthroughs in our understanding of the universe and our place within it. In conclusion, the Milky Way is a fascinating and complex galaxy that continues to captivate the imagination of scientists and the public alike. Its diverse features, including its spiral arms, stellar populations, and central black hole, offer a wealth of opportunities for astronomers to study the evolution of galaxies and the nature of the universe. As our understanding of the Milky Way and other galaxies continues to grow, so too does our understanding of the fundamental properties of the universe. With new discoveries and breakthroughs on the horizon, the study of the Milky Way is sure to remain an exciting and important area of research for years to come. Thanks for watching. Subscribe, like and share.